So first, I'm going to talk a little bit about how you can use some tools and practices to improve your API development workflow. And then Ian will do a demo showing how it all kind of gets put together. For this talk, we have the slides and the example code all available at betterapis.com. There's also some links to some further reading if you want to look into some of the technologies we're going to reference today. So everything should be linked there. Before we really get started, though, I want to go over some terminology just to make sure we're all using the same language. A lot of this will be review for many of you, but just hang on a minute and we'll get to the good stuff. So first, there's this concept of REST. It's a huge topic. I'm not going to do it justice in one slide. But for our purposes today, I just need you to know a few things. It's not a standard. This is an architectural style for building APIs. And essentially, it is using a protocol and applying constraints. So usually it's HTTP. If you apply all the constraints, you have a fully RESTful service. If you don't have a fully RESTful service. But for our purposes, it doesn't really matter. We're talking about REST-like or REST-inspired HTTP APIs. And so this means they follow some of the patterns, things like mapping HTTP methods to actions and mapping URL paths to objects or like nouns, basically. So we're talking about REST-like APIs. There's JSON, which is JavaScript object notation. So this is a way to serialize an object, turn it into a string so systems can send it back and forth. There's JSON schema. JSON schema is a specification for describing JSON data. It is itself written in JSON. So this is used in validation and in testing, and it's used internally in some of the technologies we're going to show. So then there's YAML, which is another serialization format. This one is a little more human readable than JSON. It's actually a superset of JSON. So you'll see in some places where you have a YAML document and bits of it are still JSON. And it has pretty broad language support, and it's getting more popular. So a lot of these things are written in YAML. So here's an example of a YAML document. And so if you're familiar with JSON, you can see the difference. There's a lot less quotes and brackets and commas and things like that. So this is a little easier for a human to work with. OK, so the idea for this talk came about a couple years ago when Ian and I were working together on an API team. An internal client had a need for a new feature, and it was pretty simple. So they wanted to be able to add a new record for a new type of thing in the API. So we needed to accept a post, and if everything was good, return OK. If there was a problem, return an error message with validation error, so listing out what was wrong. So we did that. We implemented a new endpoint. It accepted a post. It returned OK, or validation errors if there were problems. So great, we deployed our change and asked the other team to start testing. And they said, that's not really what we wanted. OK then, so what's the problem here? The difference was pretty subtle. Now this is just kind of like a simplified version of the difference, but basically they were expecting a nested structure, and we gave them a flat structure. The data is all the same, but the format was different, and it wasn't what their tool could work with. So we had a problem. And so we thought to ourselves, can we do better than this? We didn't want to just let our clients dictate what the API interfaces should look like, but we wanted a way for us to be able to design the APIs and get their feedback early on before doing all of the implementation and then having to redo it. So that's when a concept we'd been hearing a lot about finally started to make sense. And this is the idea of the API contract. So like a legal contract, this is an agreement between two parties. In this case, it's an agreement between the API consumer and the API provider. Often it's a negotiated agreement. This includes the interface specification. So a description of how all the requests and responses should work. But it includes other things too, like SLA, terms of service, rate limiting, and things like that. Part of this contract, though, the main part, is the API specification. And so this is a document that's machine readable, so it can be used by computers to verify the API. And it describes the requests and responses and how they work. And like I said, this forms the basis of that overall API contract. So these specification formats aren't a new idea. They've been around for a while. If you ever worked with SOAP or XML RPC services, you're probably familiar with WSDL. WSDL is a verbose XML format for describing how one of those APIs work. When the RESTful APIs came on the scene, a new format was developed called WADL. But again, it's verbose XML and generally not fun to work with. Luckily, in recent years, a new breed of specifications has come on the scene. And so we're going to go a little bit over the most popular ones. And so that's Swagger, which is being renamed the OpenAPI specification, RAML, and API Blueprint. So we're going to take a quick look at all of these. So the OpenAPI specification, formerly known as Swagger, is defined either in JSON or in YAML. The early versions were just JSON, and they were generated from your server implementation using either code annotations or tools that understand your web framework and turn it into the spec so that you can use this to advertise to clients what your API does. But then with the more recent version, it also supports YAML, and that was to better support this idea of defining the contract first. So you can develop the specification in YAML and then do the implementation afterward. So now the format is being maintained by the OpenAPI initiative, which is a project underneath the Linux Foundation. I'm going to be showing 2.0 because that's what's out right now, but version 3.0 of the specification, the release candidate 1 came out a couple weeks ago, so it will be on the scene pretty soon here. But let's take a look at what one of these specifications look like. So this is just a really basic spec. It's in YAML, and we can see it starts by defining meta information about the API. So it has things like the API name, the version, a short description, and like contact info. So this is just kind of stuff about the API. Then it has the basics for how you use it. So the host name, the base path, the scheme, so you know how to connect to this API. And then it defines the content types that the API consumes and produces. In this case, it's just JSON. But you could do things like XML or YAML and other formats. And then if you continue down in a spec, the paths are defined. And so each one of these URL routes, you specify the methods that it accepts, and then any parameters that are required or that can be accepted, and then all of the available responses. And if you look at the bottom line there, you see that there's a reference to a definition. And so that's another thing that the specification allows, is defining common objects once and then reusing them in the spec. So in this case, this foo object is used multiple times in the spec and just referenced with that ref tag. So the full version of this is on that example site, so you can see the full spec, but that was just kind of a snapshot of the important parts. Okay, so the next format is RAML. RAML is developed in YAML only, and it came out as a response to the early versions of Swagger. So RAML was developed from the standpoint of wanting to model your API first. Now with Swagger 2.0, they're actually pretty similar. So let's take a look at the RAML spec though. So again, we have just kind of meta information defined at the top of the specification file. So just information about the API. It's just basically a different format than we saw with the Swagger. And then we can define common types again. So this type is defined the same way it was in the Swagger document, so it can be reused throughout the specification. And then we define routes. So far, this is pretty similar. We're really just talking about a difference in the format and the organization. And then there's a third specification format, and this is called API Blueprint. And this one takes a slightly different approach. So Blueprint is documentation as specification. The entirety of a blueprint document is Markdown plus some extensions that are specific to this use. So we'll take a look at that real quick. So while this is Markdown, so it's a different format, we're pretty much doing the same thing again, where we have information about the API, just kind of meta stuff, and then we're going to define URL routes. And so these are defined in Markdown structures, though. So it's like the heading levels define what the routes are and what the methods are. And then, again, you can define common data structures that are used throughout the spec. So really, these three kind of cover the same set of ideas. They take different approaches. So if you're going to go this route, you have to choose one, though. And there's a few ways you can do that. First of all, is just the overall user base. They all have active communities, though the Swagger and OpenAPI one is probably the largest. When you're talking about specific programming languages or frameworks, some of them have better support for one of the other two. So it really depends on what language or framework you're implementing your API in. They, again, all have the good amount of tooling. The OpenAPI, because it's this open organization and has been around longer, has a wider ecosystem of tooling, where the other two, the core tooling is maintained by single companies. So it's tightly integrated, but it's not as broad. So like I said, a lot of it comes down to which language you're working with and which one of these has the best support for your language. But then, between the time that we proposed this talk and today, some things have happened. So the company that made API Blueprint, called Apiary, was acquired by Oracle, and they also joined the OpenAPI initiative. So they're taking part in the definition of that OpenAPI spec. And a lot of their tooling now supports both Blueprint and Swagger or OpenAPI. And then even more recently, and this was about a week and a half ago, SmartBear, the company that makes RAML, announced that they are joining the OpenAPI initiative. So it'll be interesting to see what happens with their format, because they're still coming from that approach of modeling your API first, but a lot of the same things can be covered in the OpenAPI spec. So that's something to keep an eye on. So really, again, which one of these you would want to use depends on your situation. The good news is there are tools for generating a different version or a different language of the spec from one. So if you develop a Swagger spec, you can output a Blueprint or a RAML spec. And I have links to some of those tools, so you can do that if you want to compare for yourself. Okay, so in order to define a specification for your API, there's a couple approaches you can take. You can implement first, and then either using annotations in your code or tools that support your specific framework, you can generate one of these specifications. Another option, though, and the thing we're kind of talking about, is defining the contract first and then doing the implementation. So you write the spec either by hand or with an editor or with one of the tools that are specific to the language. Define the contract and then go ahead and do your implementation. Now, in some cases, that means defining the separate document and then implementing separately. But in other cases, there are frameworks that actually integrate with the specification. And so the one we're going to demo uses the OpenAPI specification as part of its configuration. And so it's fully integrated, and the specification never diverges from the implementation. I'll talk a little more about that in a minute. So if you go through the work to make one of these specifications from for your API, you get some benefits out of it. So it's not just work for work's sake. The first one is accurate documentation. There are tools to render these formats to HTML or interactive API consoles or to PDF and things like that. Another benefit is testing. So for each of these, there are tools that take the specification and verify that your implementation actually adheres to it. So it can run requests against your live API and verify that the responses have the format that are defined in the spec. A popular tool for doing this is called Dread, and that's one of the things Ian's going to show. This supports Blueprint and Swagger or OpenAPI for doing that, for making requests against your API and verifying the responses look good. Another thing you can do if you're designing the specification first is generate code. And this can be done to generate server-side code. So basically, for your language of choice, there are code generators that would output a basic framework with stubs for all of your endpoints. Or there's client-side code generation. So if you're maintaining server implementation in one language, but you want to support clients in a bunch of different languages, maybe ones you're not terribly proficient with, you can use the code generators to make a .NET, a Java, a Ruby, a Python client for consumers of your API. And then the last thing, and the thing that we found really useful, is mocking. And you can use this specification, once it's fully developed, to mock what an API would look like and see how the requests and responses work without doing the implementation. And that's what we found really powerful. OK, so it's almost time for the demo. So I just want to tell you a little bit about what Ian's going to show you, and then he'll finish the intro. So he's showing an integrated framework. And so that's one that uses the specification as its configuration. This one is called CONNEXION, and it's specifically for Python. It's built on top of Flask. But there are many others. So if Python's not your deal, you can go ahead and look, and there are integrated frameworks for most of the popular languages. And so this uses the specification as configuration. So from the OpenAPI spec, the application knows how to do the routing, to route the requests to the right controllers. It does input validation to make sure that the requests adhere to the specification. And then it controls serialization, so what formats are output by the API. And so now Ian's going to show you how that all works.
OK, hello, everyone. Hope everyone are enjoying OSCON. And as Dave mentioned, he talked a lot about a few concepts, a few high level, and I'm sure you're all excited to see a little bit of how you can put it into practice, see this demo. So I'll do just this one slide, basically to show you, wrap up a little bit of the process Dave was talking about. So we start with the spec, and we either, if we're doing a completely new development, we're writing a brand new spec, or we're updating a spec for a feature, and we're going to see a little bit of both. Then the first benefit you get out of it is a mock server you can give your clients. And the other part of it is you can publish very easy to read the documentation out of that spec if your clients wants to see some more rendered HTML or PDF, anything like that. Then you can actually, after you maybe hashed out some miscommunication with your clients, you can actually do the implementation. And we're also going to see some validation for your implementation. So hopefully this demo part is going to work. So switch it up. Yeah. OK, hopefully you're seeing the same thing as I am. So we're going to start with the spec. And as Dave mentioned, we're using kind of an example we're calling a Better APIs conference. And it has a very simple API where you can create a new, you can register a speaker, and you can also submit a new talk. This is basically a spec using the Swagger or OpenAPI. You can see here Swagger 2.0. You see some metadata. very similar to examples that the snippets Dave showed. And here you see, for example, talks. We can get all the talks for from our Better APIs conference. And we can also submit a talk. It describes the whole endpoint and the action. It shows it needs in parameters a talk object, and gives you back a response of 201. And there is also an example of a response, this talk ID 4321. And you'll see how it all ties in a little bit. So this is basically our spec. The endpoints for the speakers are very much the same way. And you can a few more CRUD operations for the talks. So right now, we only have the spec. This is what we came up with. We want to give it to our clients. For now, as you remember, we still don't have any implementation. So the first tool we're going to use is the framework Dave mentioned called CONNEXION. And the nice part about it is, and there are a lot of other tools that do it, but one of the features that CONNEXION gives you is the ability to run a mock server. So all you need to do is, with the command line, do CONNEXION run, point to our spec, which is Better APIs YAML, and tell it, right now, I basically want to mock all of our endpoints. And I'm going to run this. And I'm going to run it, as you can see, on port 5000. Then, if I go to, I have a couple of requests that I set up with Postman. And this is the tools that I'm using right now. So I want to get, for example, if I'm one of the clients for this API, and I want to see, OK, I'm going to submit a GET request to /docs/1, and going to see what is the object that I'm getting back. So right now, I send this request. And sorry if the font is not big enough. But you're getting back a response object. I'll try to go through it. And you can see back a response. And CONNEXION is basically taking the examples array that you defined in your spec, and it's giving back to your clients an ability to program against this example to be able to, OK, I know this is going to have an abstract. This is the format of the date. So the clients don't need to go and read a bunch of documentation. They can actually program against it and see live examples. Then your clients after that, OK, this is nice. This is awesome. But hey, what's going to happen once I actually submit a talk? I want to send a post request to /doc. And I want to create a talk. I'll give it some title. I'm going to do a speaker ID and an abstract. And I'm going to submit this. And the mock server received that. And you said, OK, here's your response back. This is talk ID 4321. And this is the example the customer got back. But as Dave mentioned, sometimes when you talk to your clients, you define your spec, some miscommunication happen, and they might understand other stuff. So for example, here, one of our clients, they thought, hey, we need to specify this duration. It's going to be 75 minutes. But for some reason, maybe they thought this will be a string. So one of them will go, and they do their implementation. They submit this against our mock server. And they get a response back without us doing actually implementation right now. They still get, if you're able to see here at the bottom, details of the error that 75 is not an integer. The status is 400. And I think this is a very neat way to flesh out those kind of miscommunication even before we got to the implementation, and would have saved me and Dave with the example that he showed where some of our internal clients didn't really understand how some of it is going to look. So this basically gives you an example of the mock server. The other part is, as I mentioned, is also publishing your spec. So CONNEXION is actually giving you that as part of a there are other tools, as we mentioned, but CONNEXION gives you also a representation of our Swagger spec. If we're looking at this one. And well, it worked before. I do. That's the. Oh, thank you. OK, so now we have our representation. And this is very basic Swagger UI HTML representation of the whole spec we got. But it's really nice the fact that we're already using connection. We're going to use that also for the implementation. So it gives you additional value without actually introducing another tool into your stack. You get this representation you can show your clients. They can hit this and see all of the endpoints. They can see the get endpoints as /speakers. And it shows them the examples. It shows a little bit nicer implementation, representation. And it also shows them here if you have a post. It gives them this console. They can do that. But this tool, specifically Connexion, I don't think supports much of templating to really work with customize the HTML to how you like. But there are a bunch of other tools that let you take your Swagger spec or any other spec, if it's RAML, Blueprint, and have HTML representation very similar to this. So I think we covered the fake it part where we created the spec and we created the mock server. And we also saw how the clients can have some HTML representation. Now, how about implementation for this? So as we mentioned, we're using this framework called CONNEXION because it's very nice about tying all of this together, all of this framework, all of this process, how we're working with this. And here we built our application. So Connexion is running on top of Flask, which is a Python micro framework for web development. And usually in Flask, as in other web frameworks, you would need to define your controllers, and then you need to define a configuration where you're specifying this controller is for this endpoint and things like that. Connexion actually knows all of this information is inside of your spec. So we don't need this. By default, it's going to go and based on finding this speaker PY file, it's going to go and find this get and post and put methods, and they just use the logic inside of them. You can also customize it a little bit. You can explicitly tell it where is the location of the function that implements the logic. But for this kind of a simple implementation, the default works very nicely. And we have an application where we have our controllers. And for the speakers, we have a controllers for our talk. And this is all the implementation, basically. So we're going to experiment that for a minute. And so this is basically our small Flask/Connexion application. And I already have the environment set up here. And all I need to do is do Python better APIs. And this would run my application. So I'm running it on port 8080. And just to see how it runs, I have another request here where we're going to send the submit Dave, register him as a speaker in this talk for this conference. So we got him as speaker 1, and we can send another one, do a double registration for him. And then we'll submit a few talks under Dave. And as you can see here, our connection routes exactly to our implementation. And all of this is working, basically. So this is the part that we're implementing, right? But we also said that, hey, we already have the spec, and we have our implementation. Then we want to do a small validation on it. So I think they've mentioned a tool called Dread. It's one of the tools where it actually reads your spec. And based on the spec and the JSON schemas that defined there, it's going to use some example parameters to send requests against your implementation and going to make sure that there is no drift between your implementation and the spec that is defined, because the specs might change, new features and stuff like that. So we have here, for now, we're just going to test the get methods. In order to test puts and posts, Dread provides a framework to create hooks where you can populate data in your database to do a whole flow of testing. But for this example right now, we're going to test just the get. And if you run Dread, oh, it should have been different. Oh. Why isn't this? Yeah. this shouldn't have been this way. So just a minute. If I grab it from here. Okay. So if you bear with me for 1 minute, it really worked much better practicing this morning. And this should be 8080 actually. Okay. So I think I killed this. So we need our implementation. You run dread again. Nope. Oh. Okay. Okay, I think I was just in the wrong directory before. Now it's actually much better. So you can see that it tested by sending the GET requests over to our server. And it tested all of those. And we had 4 passing tests. So you can see how your spec that you have spent time building is actually tying up to our implementation. And testing that right away. We have a couple, 7 more minutes. OK. So the last part of this I want to show is because we built the spec, we did the implementation, so we're done, right? Well, yeah, usually not. As you know, usually we add features and stuff like that. Things change. So one of our clients actually told us, yeah, we actually saw that we're going to have another endpoint where we're going to submit reviews. So we're saying, OK, sure, we can do that. And we're going to update our spec. And they have a new spec up here now that actually has some reviews endpoints, right? So we're seeing here, should be a little bit lower. Yep. So we have our reviews endpoints. We can make a post, and we can get a certain review. So we defined that. That's awesome. And then we know we already have connections. So all we need to do is define a controller for our review. And we're going to do that. And here we go. We created this controller with the get and the post. And no boilerplate code we need to do for that. Then we also need to persist this to the database. So we need to create this object for doing persistence in the database with the review object. So we updated all of this implementation. We have this new feature on. And I'll restart our connection application. And then we have this last request we have from here where we're submitting actually a review saying this is an awesome talk. And we populated this information. Then the way that this ties in is right now we updated our spec. We also updated our implementation. But we could have forgotten one of them. We could have forgotten updating actually the spec and run away and do implementation. All we need to do is run dread again. And actually, dread is going to keep us honest. And now, instead of having 4 passing tests, we actually have 5 passing tests, where we actually see that without updating any test code, actually, this was updated to have more testing now. And I think that's all for the demo. Even the small hiccup was almost on time. Oh, I think that switched for some reason. Cool. David's wrap it up.
Yeah, and so Ian just showed you one example of doing this, and I just wanted to emphasize that you don't have to use the specific tools we showed to follow these practices. There are a ton of these integrated frameworks for either OpenAPI, a couple for Blueprint, and a couple for RAML. So if there's a specific language that you're doing your implementation in, I'd recommend looking into which ones are supported for you. Mocking can be done by some of these frameworks. So this one does it built in. But there's also standalone mock tools. There's a Java one, a Node one, for running mocks based on one of these specs. So even if you're not using one of the integrated frameworks, you can still do the mocking from the spec. And then there's tons of tools for validation and testing. So we covered Dread, which is probably the most popular, but again, there are specific tools for each of the languages. So like I said at the beginning, we have some more resources linked at betterapis.com, so you can look into some more of this stuff on your own. And I'd just like to ask you one favor. Please make sure to leave feedback for this session so we know what worked for you and what we could do better next time. And try to do that for every other session you go to, too. So thank you very much.
Thank you.